Hello everyone. Today we are going to start this very interesting journey of learning core Java. But before I begin, I would like to tell you that learning core Java is very simple. It's not much different than the language which we usually use for communication, for example English. Only difference is English I am using right now to communicate with you, while Java is a language which you are going to use to communicate with the computer. So, if someone has to start learning English, how will he begin? First of all, he will start learning alphabets, then words, sentences, and the grammatical rules. In the similar fashion, for Java also, we have certain set syntax and certain rules. Once you know about these rules and syntax, writing Java code will not be at all difficult for you. So let's start. So let's see what we are going to learn today. First of all, before jumping on to the rules and syntax of Java, I would like to give you a brief introduction about it. Then steps to install Java. First Java program, data types, and operators. Let's try to understand how computer works. First of all, what is a computer? Computer is an electronic device. Since it is an electronic device, only thing which a computer can understand are the electronic currents. That means if you have to give some instructions to the computer, it has to be through electronic currents. Now, how will you communicate your instructions to the computer? That is through a unique sequence of electronic pulses. When you give a specific sequence of electronic pulses to the computer interprets it and does some work. In computer language, we call this sequence as binary. Let's have a look at the binary. The sequence of zeros and 1, which you see on the screen right now, is one such binary. 1 in this sequence represents the presence of electronic pulse, while 0 represents the absence of electronic pulse. Therefore, by giving such sequences to the computer, we can communicate to it. So, we can communicate with the computer using binary code. Then what was the problem? Why did all the languages came into picture? Let's try to understand this using early man's example. Imagine our early man is thirsty and he needs a glass of water. Now, if language was not developed at that point of time, how would he have communicated to the other person what he wants? Maybe using the sign language? But using sign language, it would have been very difficult for him to make the other person understand. So, what could be the solution? Solution is the language. Once the language would have been developed, just by saying a single word, water, he could have got what he wanted. Similarly, in the case of computers as well, although we had the binary pattern for communicating with the computer, but just like the sign language, it was very hard to remember. Let's take an example. Suppose we have to add two numbers. Now, to give this command to the computer in the form of binary pattern would look something like this, where the two numbers as well as the operation add, everything is represented by the binary pattern. Isn't it very hard to remember? And this is just for adding two numbers. Imagine if you have to do some complex programming, how difficult it would be to give these binary patterns to the computer. To solve this problem, again we had the same solution, language. But this time, language was developed to communicate with the computer. So, in the language, simple commands, for example, in this case add, was given to the computer. And Computer used these commands to interpret and do some work. The first such language which was developed was assembly language, and it had many such commands which programmer used to communicate with the computer. Assembly language is the most basic or elementary form of software development language. It provided all the commands and syntax required by the programmer to communicate with the computer. So instead of binary code, programmer can now use this syntax. Now, you must be wondering that computer can only understand electronic pulses or binary. Then how was it able to interpret the commands given in assembly language? To understand this, let's take an example. Suppose you do not know Chinese and you have to communicate with another person who understands only Chinese language. Is this communication possible? It is only possible if you have a translator who can understand what you are saying in English and then translate it into Chinese for the other person. Similarly, to understand assembly language, computer needed a translator which can understand the assembly language commands, change it into the byte code and feed it as input to the computer. Assembler is a program which acts as a translator. The work of assembler is to take input as assembly code. So whenever programmer writes assembly code and feed it into the assembler, the work of assembler is to change this assembly code into binary pattern. And this binary pattern acts as instruction to the processor. Now nothing has changed for the processor. It is still taking binary code as input. Therefore, it is able to interpret the commands given in assembly language. But there were problems with assembly language as well. First of all, assembly language was platform dependent. What is a platform? Platform is a combination of operating system and processor. One such example is Wintel, where operating system is Windows and the processor is Intel. As bytecode is dependent upon the platform and it changes for the platform, similarly assembly code also changed from one platform to another. This platform dependency became a limitation of assembly language. Another problem was that assembly code was very basic or elementary language. So, doing complex programming in assembly code was very difficult. Therefore, another advanced language came into picture. It was C language. So, to solve the problem of assembly code, C language came into picture and it provided much more ability to the programmers to write complex programs easily. Now, how C code works? C code is changed into the assembly code using a compiler. So, whenever programmer writes C code, it is fed as input to another program known as compiler. Work of compiler is to change this C code into assembly code. Rest of the flows remain same. But platform dependency was not removed even with the C language. Although it was advanced and provided many easy functionalities to the programmers, still platform dependency was there. Now, why was C language platform dependent? Look at this picture and you will get to know. As we know that C code is changed into assembly code and assembly code is platform dependent. So, assembly code for platform 1 will be different from the assembly code for platform 2. Therefore, the compiler which converts the C code into assembly code has to be different for platform 1 and platform 2. Hence, Platform dependency was not removed in case of the language. Finally, Java came into picture and it solved the problem of platform dependency completely. You must have heard that Java is a platform independent language. Let's try to understand how this was achieved in case of Java. Thank you for your time. For complete course, please contact us. Contact details are given on the screen.